Okay. Can we begin to gather and hello everyone? Hello. This is your chair speaking. Excuse me.
Hey! Go now.
If we could go ahead and get started, that'd be great. Would somebody in the back mind closing that back door? Just to cut down on some of the noise. Okay, perfect. First thing before we get started, we are going to need some minute takers. Do we have any volunteers? Minute taker volunteers. There's a notepad. You can do it collaboratively. It's linked from the agenda. It's super easy. Really? Nobody? I see people studiously trying not to meet my eyes. All right, so we have to do minutes, which means we need a note taker. So is somebody willing to do some notes, please? It's not that hard.
This is David. I'd be willing to take notes after I finish presenting.
Well, thank you. Others who did not volunteer, please feel free to add to the note page. It's linked from the agenda. Okay, so with that, we'll go ahead and get started. This is the Jose Working Group. As a reminder, you agreed to this when you registered to attend this meeting. This is the note well of the IETF. It has all of the policies and processes that are to be followed. If you have any questions about the note well, please feel free to ask either John or I or Deb is our area director. Just a couple quick things that are other reminders. These meetings are for professional collaboration. We want to maintain an environment in which everybody can participate. And we do not in any way condone harassment. If you feel that there is any behavior that you are not happy with, please bring it up. Thank you. Some additional meeting tips. Be sure that you've, looks like we have a fair number of people I recognize here as experienced IETFers. Don't forget to use the QR code or sign into MeetEcho. Please use that tool to join the mic. Please always go to the microphone when you're speaking. And we will be using the queue to be ensure that the remote participants also have a chance to speak. And with this is our draft agenda. Do we have any agenda bashing? Nope. And I think, David, are you first?
I am.
Do you want to drive your slides or did you want us to?
I don't have that many. I can let you drive them.
Okay.
Okay, everyone. Nice to talk to you today after lunch. We'll see what the energy's like in the room. Unfortunately, I couldn't make it to Vancouver, but I'm really happy to join you and talk about some of the updates we've had to the JSON Web Proofs family of specifications since IETF 119. Next slide. So since the last IETF, we've had a lot of normative and we've had a lot of editorial additions. The draft that was published a few weeks ago, right before the cutoff, was primarily internal changes. So we had a number of examples that were very dated. They'd been hand edited since the initial draft was accepted by the working group. Weren't necessarily the prettiest things either, and of course, hand editing means they probably didn't cryptographically validate unless we did something majorly wrong with the cryptography. So behind the scenes, we refactored things to create kind of a common basis of examples and to write a implementation that would go through the steps of JWP, generating a lot of artifacts that we could pull in. So we kind of refactored the documents to move algorithmic samples all to a single appendix underneath JPA, and those are now all being generated programmatically. The draft 4 didn't have the change for the Mac-based algorithm. That was in draft 5, which will be the next slide in a second. We also moved to BBS, which is currently on draft 6. It has had a couple of changes, but it's starting to slow down greatly in terms of the core cryptography. So we felt comfortable dropping the draft suffixes that we had on the two algorithms, BBS and BBS proof. So those are now just BBS and BBS proof, with no draft 3 or draft 5 suffix. There was a breaking change in draft 6 in terms of the actual output, but it was relatively small in terms of code change. We also moved to the latest BLS key representation, which uses the XY curve and properly capitalizes people's initials. Next slide. So draft 5, which was published last night or this morning, depending on your point of view, had a bit more substantial changes in it. So way back in draft 3, we changed the proof section from being a single octet string, similar to JDS and having a single binary signature, to actually being multi-part. So basically, it's now an ordered array rather than a single string. And we had that there, none of the algorithms were using it, but in draft 5, we refactored the single use in Mac algorithms to actually use that. This is mostly there to provide them a bit of structure without having to invent it themselves. It's also there so that when we start doing other representations, such as a CBOR representation, we don't have to worry about people inventing different kind of structured representations of this information. So if you're unfamiliar with the algorithms, both single use and Mac, they wind up having at least one signature, potentially multiple signatures, multiple Macs. And before they were concatenated into a big binary message that the algorithm had to pull apart. And now through the wonderful wonder of tilde delimitation in the compact form and arrays in the JSON serialization, these are now represented as individual binary parts. So this does slightly increase the size of the messages, but we get a big benefit in that the algorithms don't have to encourage people to do binary buffer manipulation. That winds up being specific to the cryptography used and the size of the JWP, how many payloads are in it. So hopefully this makes it more challenging to have an unsafe implementation of these specs, because these all now wind up being the input to the particular cryptographic algorithms that you don't need to kind of pull apart. If you had something more complex as an algorithm that needed more structure, you would still need to invent something like an object structure with optional parts. So far, I don't know of any that are going to need that. But this did also greatly simplify the implementation in the text, not having to pull these apart manually. We found out that we had some basic secure URL encoding leak into the algorithm. So we had some values that were being composed of, say, the base64 URL encoded version of a particular payload rather than the binary form. So this got changed. This was breaking if you have an implementation, but also removes a bit of a foot gun. So now algorithms are meant to operate, be binary safe, to operate on binary data, and the realm of basic secure URL encoding is for serializing into compact and JSON forms, and for representing things within, like, say, a JWK. Finally, a big change, we were, with the single use in Mac, composing things using JWS. This was very clever, but I'm sure people realize that the consequence of clever is you have to explain which part is the magic trick. It becomes a lot more difficult to explain, and wasn't necessarily bearing any weight in terms of its complexity. It wasn't necessarily easier to use, say, a JWS ES256 signature that we synthesize a header and then extract the signature from, versus just saying use ECDSA with the correct curve on this binary data and then use the signature. Another benefit, this simplifies the construction. We don't have to explain the magic trick, and it removes what could be perceived as a dependency on a JWS library to implement these algorithms. It also means that when we do something like a CBOR representation, that there isn't this confusion about why algorithms are doing basics for URL encoding and decoding and JSON-like headers internally. Finally, we registered a structured syntax plus JWP for use by applications. Next slide. So speaking a bit of things that are going on related, BPS, like I said, has draft 6. This seems to be getting a lot closer to stable, and they're shifting their focus on extensions. So one extension there is blinding for signatures. So how can I get data included, like a protection for a payload, for instance, where the issuer doesn't actually know the payload contents? So this is very specific. You're not going to have someone provide sensitive information without the issuer correctly knowing and being able to vouch for it. But it does mean that you can have secret values that the issuer doesn't know, that the holder of the credential does, that can be used for a bit more of proof of possession. So this is very useful. Basically, for those who don't know, the ability to do a BPS proof relies on you knowing all of the values, all of the data of the credential before redaction. And so these blinded values mean that no one, not even the issuer, would be able to do the proof, only the holder who knows that blinded value. Orthogonal, I'll say, is pseudonymous identifiers. So based on the identity of the verifier, we can generate basically a point, which would wind up being a unique value for that verifier, pretty much based on any payload. So this would allow us to, say, we'll go for driving licenses, have a driving license number and not disclose that, but use it as input to generate a stable identifier for sharing with a verifier. So this starts to leak from, say, identity verification a little bit more towards authentication, or at least simplifying the recovery process. If you can know that the document has the same identifiers without necessarily disclosing them and having them being a linkable value. This combines with blinding in that the pseudonym can be based on a blinded value. So I can basically have an identifier that the issuer wouldn't even be able to regenerate. So whether or not how you use pseudonyms, what you base it on, whether it's blinded or as an application level decision, but these are really useful extensions for, say, people who want to use this work for credentials. I mentioned the BLS key representation updated. Another parallel work would be over in um, the OAuth working group on SD-JOT. I believe they're getting very close to last call. So a lot of great work happening over there too. Next slide. So next steps. There's more work than is just on this slide, but these are the areas that we're somewhat focused on in terms of priorities. So first up, we want to make sure we understand how to use these valuable BBS extensions within JWP. GPT, the equivalent to JOTS, may get some refactoring to accommodate these, but very useful for some of the use cases that we see people wanting to use this work for. Another one is single-use BBS and Mac. They all have ways to kind of confirm that who the holder is. So some sort of proof of possession. For BBS, this could be based on the blinded values or just knowing all the attributes. For single use and Mac, this is based on having an embedded ephemeral key that the holder knows the secret for. So you could say that BBS, it's somewhat intrinsic in the proof on presentation, whereas the other two, it's a bit more extrinsic, that I'm using a signature from a key that's included to do this proof. So we were looking at moving single use and Mac to actually use JWS for those extrinsic holder confirmation steps. So basically sign over the presentation in order to prove that it's actually coming from the correct holder. This should mean a little bit more agility because right now the cryptography that a holder could use is going to be tightly bound to the algorithm of issuance. So if I want to issue based on, say, EDE 25519, but the holder is using a cell phone that has P256 curve in its HSM, I can't really do that today with the primitives we have. So looking to move to that, we probably will have a special form for that, just for compact representation, but hoping that simplifies things. We're also, some of the cleanups in the current published draft have been trying to move towards alignment with having a Subar cozy-based representation. We're hoping that the algorithms are identical. The outputs are pretty much identical, and the difference winds up being things like protected headers and binary versus basic four-year-old encoded representations of things. So we're hoping that we can, because we're at an early stage, kind of design for a great amount of reuse for the representation there. Finally, we're continuing to scout for additional algorithms. There has been concern in the past about single use in Mac and how they don't have the newer properties, zero knowledge proofs of generating pseudonyms that something like BBS has. And the challenge has been having enough algorithms that we can say, okay, we don't necessarily need those. I think that they are useful for people to have more algorithms that work with off-the-shelf, like HSMs and stuff today. But if that case is to be made, then we really need to have additional algorithms that we can represent that have the properties that we're looking for. And so far, the level of specificity that we really want, that's pretty much just been BBS. I think that's it for me. What was the last slide? So yeah, we are looking for more feedback from implementers. We know this is a bit early, especially considering how many immediate deployment needs that are coming out of EIDAS 2, but what sort of use cases people are looking for, what they would like us to focus on next. and always looking for implementers. And again, we're looking for people who might be able to provide a little bit more um, feedback, inspiration, pointers towards what we could do for additional algorithms, especially if we could find something that was multi-use unlinkable, but also post-quantum secure, like say a Stark or a lattice-based zero knowledge proof. That's it for me.
Are there any questions for Mike, for David? Okay. We would like to see some additional review and discussion of this on the mailing list. Also, David, if you could get with your authors, we have set up we've begun to set up the GitHub repo for the Jose working group, and I'd like to have these drafts moved over to there.
Okay. And I tried to help with that administrative kind of hat on. So if they run into problems like maybe the repo that they would like is being taken by someone else, that someone else might be me.
Oh, so you're.
I've tried to reach out with people in the past in order to get that process started and haven't had much luck. So if people want to do that now, then I'll help wherever I can.
We have one set up by the Secretariat now. I couldn't figure out who owned the repos that I found that were related to Jose and GitHub, and I couldn't get anybody to answer me on who had set them up. So we set up a different one.
Okay. Well, I can free up the name and we can move it.
Okay.
If that's what we'd like to do.
Yeah, I think there's a fairly simple process for doing that. So thank you.
Mm-hmm. All right. Thank you, everyone.
All right. Next is Mike.
And I'll let you drive my slides. Hi, I'm Mike Jones. I know many of you. Thank you for coming. I'm here to talk about the fully specified algorithms work that we've been doing for a year and so. Next. So I'm not going to take your time saying what we're doing or why we're doing it. We've covered that a few times. There's plenty of material to understand that you can reference if you would like to catch up on the motivations and goals. Next. So we've made a lot of progress since IETF 119 in Brisbane. In Brisbane, we described the current working group draft. And at the time, there was one big outstanding open issue in the working group about how we wanted to handle things. In particular, elliptic curve Diffie-Hellman encryption. We eventually decided, look, let's just comprehensively describe what solving that with fully specified algorithms would look like on list, which we did. If you search for the mailing list for a subject line, fully specified ECDH algorithms in April, there was a good bit of discussion on that. Some people saying, well, we don't need all of that. Other people saying, well, but it's an actual problem. But we got the data on what we might want to do about the remaining open issue, which was great. We then held working group last call in May on O2. And I will say there was a lot of actionable constructive feedback received. I was really gratified by the level of engagement with the working group and got some really nice comments like, I don't know why somebody didn't do this a long time ago. Ori Steele and I worked pretty diligently going through every piece of feedback we received and we published O3 before the cutoff, incorporating the working group last call feedback in July. Next. So this slide, all those bullet points are the history entries for O3. So that's a comprehensive description of what we did in the latest working group draft. There's now going to be about a half dozen slides where I drill into some of these things that we did to make them completely obvious to you what we did. Next. So one of the most popular working group pieces of feedback was for COSE, make the status of ED 25519 and ED 448 on par with support for the NIST curves. Used to be recommended no, now it's recommended yes. It's a very simple change, but it was a very popular change, and so we were happy to do that based on working group feedback. Next. In COSE, because of the polymorphic nature of ECDSA, you could either do ECDSA with kind of traditional algorithms, or it was, I would argue, ambiguous in the COSE spec, in the standard, about whether you could also use some of those algorithm identifiers with brain pool and other situations. So we got specific feedback saying, well, look, some of the MDoc deployments, in particular for mobile driver's licenses, particularly in Europe, are using brain pool curves for some of the signatures. Please let's not strand those COSE implementations and not give them fully specified algorithms. So we did. Again, very simple to do. And that's, again, text straight out of a table in the spec. Next.
Do you want questions now? Just somebody, Philip?
Hi, Mike. Hi, everyone. On that same note, I recall a couple months, maybe a year ago, I finally figured out who was trying to do brain pool curves in Hose, and it was the German Health Institute, something like that. So I'm not advocating for it, but maybe I'll try to find out the agency who specified using brain pool curves with Hose, ping you on them or ping you somehow and see if they would like us to do the same for Jose. Obviously, if there is also wide consensus that we should.
Thank you for speaking up about that, Philippe. I will say that one of the kind of intentionally conservative positions that Ori and I took with this work was we did not create algorithms to do things where there were not already registered algorithms to do them. So, for instance, we could have also done Jose registrations for brain pool algorithms. We did not. COSE did, so we did for COSE. But because there's no Jose registrations for brain pool, we did not do it. Now, it would not be hard for a different spec or a future version of this spec to do so, should the working group by popular acclaim say, let's do that at the same time. But we intentionally did not create new functionality.
Okay, thanks, Mike. That makes sense.
2 points. I can help confirm about brain pool curves for Jose. Second question, for the COSE values you're assigning to these curves, where did you get the numbers from? -261 to -264, the range.
There's a big table in the IANA algorithms registry, and there's many allocations already. Those were chosen to be in the 2-byte range, one of the two byte ranges, so that they're not using up the rare 1-byte numbers, which is why they're greater than an absolute value of 256. And there's a small number of already registered things starting at -256. Now, why they're minus? Jim Schad registered minus numbers for signature algorithms. That's probably lost in history. Some of you may know. I just followed the pattern.
So to follow up, the reason I'm asking is because, as far as I'm aware, where these curves are needed for COSE is mobile driving license specification in ISO, and that is an already published ISO draft, and it has defined different COSE values for the same algorithms and curves.
No, for the curves, not for the algorithms. They didn't publish algorithm identifiers. These are algorithm identifiers, not curve identifiers.
So you are aligned with that draft?
Yeah.
Okay, thank you.
I mean, and when we get to a later slide on deprecated, I'll talk about, if you would like, the fact that MDL could keep doing what it's doing if it's already working. But Kathleen.
Kathleen Moriarty, I can help with that question from the time frame. The minus was that it was starting to move out of favor as a caution, right? So it's the terms you had mentioned previously that were just defined. That's what the minus was representing.
Oh, interesting. I did not.
Yeah. So for those that don't know, I was the AD at the time, which is why I remember.
Yep, very good. Thank you. Anything else on this slide? Otherwise, next. ECDH, again, that was the open issue when we met in Brisbane. And this is where we ended up with an engineering compromise. We wanted to capture all the good dialogue that had come in as a result of the mailing list discussion. And Ori and I, who's leaving, created a appendix in the current draft, which captures what you could do to register fully specified ECDH algorithms for all the corresponding Jose and COSE algorithms that are polymorphic. But people said, A, this is a problem, but it's not as big a problem as we want to register 18 things. So we compromised. We, for both Jose and COSE, defined one fully specified ECDH algorithm for each of the kinds of uses. Those algorithms use the most popular cryptographic functions today for those things, which are the P256 curve, and when you need key wrapping, AES 128 key wrap. You could register more in another spec. You could even tell us register more in this spec. But we register 2 for Jose, 4 for COSE. And that's, again, a compromise, an engineering trade-off based on the best synthesis of the working group feedback that we could put together next. Oh, we have Brian. We have a queue.
Brian Campbell. I may have different interpretations of what took place on the mailing list and so forth, but I was not aware of anyone actually asking for algorithms to register. There was varying degrees of not worth it to this is a terrible idea, please don't do it. But I don't think there was anybody that actually wanted it, or if they were a very small minority. I would say that registering a small set is maybe even, it doesn't feel like a good engineering trade-off to me. It feels more like the worst possible thing that could have come out of this. Sorry, that's overly, I would I'm very much opposed to registering anything here, especially a small set of algorithms for a problem that n- n- no one really seems to have in practice. And this would potentially create a significant number of interoperability issues and maintenance difficulties for maintainers of such libraries.
Okay, Philip?
Like Brian, I was surprised to see O3 with these registrations. And just to kind of nail on the point, there are two for Jose, but there's no X25519. I know he said tell us to register more, so I'm saying, I guess what I'm saying is either don't register everything, or we need X25519 for Jose as well, at least to have a modern alternative to P256.
To both of
But
your points,
likewise, I would much rather that we don't do these registrations as a maintainer.
you would much rather what?
I would much rather that we do not have these registrations, and I'm speaking at this point as a maintainer of a couple of libraries.
Okay, I mean, I could go back and find on list the person or persons that said that it's a problem in practice. And we were trying to, again, cater both to people who said it's a problem and not a problem. Is this the right trade-off? That's up to the working group. That's what we did as a result of the feedback as we understood it.
Hi, this is Hannes. I think it's good that you do it. I've worked in a suite firmware encryption with COSI, and there all these different variations are really a problem. And some of them have certain features and others, or combinations of algorithms have certain features and others don't. So I think it's a good idea. Also using P256 R1 is also a good choice instead of curve 24519, namely because in the environment we have been using is IoT devices. There's often a lot of some of the curves 24519 are not that frequently used because there's also hardware acceleration for the NIST curves available. So there, that's a very good choice. I'm sure that maybe there are other uses of COSI for other algorithms. So presumably like the 4 you have probably do the job, but I find this is a practical approach.
Can you write that on list? I doubt that the minute takers got all of that.
I haven't posted that on the list, but I can do that, no problem.
I would appreciate that. Thank you, Hannes. Next. These two are quick. This is what we actually registered or proposed to register in the current draft. These are the two Jose algorithms. Next. These are the 4 COSE algorithms. The reason there's twice as many is COSE uses both ephemeral static and static modes, whereas Jose only registered ephemeral static algorithms. Next. The other interesting discussion that I appreciated was, what does it mean for something to be deprecated? And what does it mean for something to be prohibited? And one of the things that I'll at least take partial blame for when we were finishing COSE is I thought about insisting that the algorithm registration criteria, the recommendation criteria, be described the same between Jose and COSE. I didn't. I mean, Jim ended up with yes, no, deprecated, and something else. Whereas we took advice from Sean Turner, who was our area director at the time for Jose, and Sean had recommended both deprecated, prohibited, required, recommended, optional. So somewhat different vocabularies. And we did not want to try to completely bite off unifying those vocabularies. That ship has sailed. But in terms of what it means for something to be deprecated, there were useful discussions on list where some people felt like deprecated meant what Jose meant by prohibited, which is you must not use it. Whereas the Jose version of deprecated is used for algorithms like AES-CBC, where, you know, be careful what you're doing, but it's not prohibited. And so in order to put these discussions to bed for future registrations, we thought, let's at least define these terms, neither of which was actually defined in either spec suite, and use the same definition in both cases. So to Christina's point about brain pool, we are just deprecating the algorithm identifier used by brain pool in MDL. We are not prohibiting it. That means if you have an implementation that's already using the polymorphic identifier and it's using it with a brain pool curve, there's nothing saying you can't keep that working. Whereas deprecated means if you're doing a new thing, try not to do this anymore, as opposed to prohibited, which says, you know, stop doing this right now. Prohibited is appropriate for things like when there's a security vulnerability found in an algorithm. So we tried to clear that up, at least for purposes of Jose and Jose. Thank you.
Kathleen Moriarty. So deprecated for drafts means this is just not something you should do anymore, right? And obsoleted, something can be obsoleted and you'd still do it, right? Because there is a subsequent version that technically replaces it. So if you look at TLS 1.2, it's obsoleted by 1.3, but it's not yet deprecated because nothing's wrong with it. I think changing this so that this deprecated means something different than that deprecated could be quite confusing. And then adding a prohibited. Right, so I think what you're adding might be confusing, at least, you know, if you're going across the IETF and thinking of the terms.
And John Mattson made that point that deprecated is used in some drafts like TLS 1.1 die or whatever it was to mean stop using it. Although in fact, the term isn't defined in those drafts. I read them.
It's like the top level in the tracker information.
So
like when a draft is deprecated or obsoleted, I'm talking IETF process level.
Status of the drafts as opposed to things in the drafts.
I know, but do you want to introduce a different way to use the same term?
They already are. I mean, the point I didn't make yet on this slide is, and again, this came from Sean Turner, who was our area director at the time. He suggested these uses of the terms in Jose, and they're already in the spec. And if we use these definitions, we don't have to change any registrations for Jose, and we don't have to change any registrations for Jose. If we change the meaning of deprecated to mean what's currently prohibited, we would have to change a bunch of registrations, which doesn't seem like sort of minimally invasive. But this is a good on-list discussion. I don't so much care what terms we land with. I do care that we land with terms that are well-defined. Thank you. Next slide. All right, so where are we, as I see it? and as Ori sees it. Draft 3 solves the existing problems we were chartered to solve. The trade-offs are based on extensive working group feedback, and I'm really gratified how many people spoke up and cared about these issues. This was not like barely participation. There was a lot of traffic. And so it took us a month to produce draft 3 because we wanted to do a thorough job of incorporating everything we could that people said. So thank you. It tries to make a trade-off between immediately solving the problems that people have identified as immediate pain points, while documenting how future specs can solve additional problems that people aren't yet jumping up and down and saying the world's on fire because of this. And importantly, one of the main missions, and this is in the charter, is to prevent the problem from getting worse, which it does. And again, we appreciate the vigorous engagement that we've received. I believe the draft is substantially improved because of it. Next. Last slide. We suspect it's time for additional working group last call, but we can have a discussion on that point, and it's the chair's decision.
Brian?
I will note that I haven't read the new draft yet. I apologize for that. I hate it when people stand up and say that, but I haven't had a chance to yet. I am very much opposed to the introduction of a new algorithm that I don't believe was anywhere in the discussion of last call, so I think that was inappropriate to add. That aside, I would note also that the only feedback in response to the update responding to the last call feedback that's been received on this was basically a broad strokes mention that this was a broad stroke statement that it didn't address any of the feedback therein received. I'm speaking on behalf of someone else now, but I'm pretty sure they're in European time and not present, so I'll do that for them. So I don't think we're ready for a second working group last call, and I actually think that some of the problems with the potential deployment problems around the particular curve and signature algorithms are pretty pressing. I know there's people that are wanting to have a solution in place for that. And I personally think it's unfortunate that this whole thing's gotten caught up in the discussion of and attempts to address the ECDH problems that are not anywhere between not as pressing a problem and not a problem at all, whilst also introducing potentially new interoperability problems and holding up the work that is really pressing and people are asking for from progressing. So yeah,
Okay.
not a very uplifting comment, but it's what I got.
I have a couple of responses to that. You're right, the only person that responded to the working group last call emails that Ori and I sent was Neil Madden. And, you know, Neil's on record as saying in so many words, I don't think we should solve these problems. So it is consistent that Neil responded saying, I don't think this did what I was asking you to do.
He actually did also acknowledge, though, at this point, he thinks it should just be rewritten to solve the.
Speak louder.
He did also just acknowledge in that email that he thinks it should focus on solely the problem of the EDDSA issues and the two various curves. So in a way, he was giving to what the original goal of the draft was and allowing for that to go ahead, not allowing, suggesting it be that way, and asking that the ECDH stuff be taken out of scope. But
no, I hear you. I mean, the other thing is, you and I have both been through a lot of last calls. Generally, if you respond to people's comments and they don't say anything, that means they're okay with it. There was only one person we sent a response to out of about 10 that disagreed with the response. And it's unsurprising because he disagreed with the work for the most part. I mean, to your point about not being comfortable with introducing ECDH algorithms that are fully specified, that seems like a really good last call comment for you to make.
Well, I haven't had a chance. I don't love the silence is considered consent approach. I understand why you have to take it sometimes. So consider this, I guess, last call comment that that stuff should be removed. But it also gets back into some of my prior comments, which were misconstrued as support for introducing those algorithms when I was just toying around on lists, considering what the various combinations could look like. And I listed out a list that I was trying, I'm not even expert in this, that seemed too long already, trying to just play with the ideas, and hinted at the end of it that that was probably not a good idea and that I was uncomfortable with the idea of introducing them at all. You represented that on list as being supportive of, and even suggesting that those algorithms be added. So that I have a little pent up dissatisfaction with the way some of this has played out, and I don't feel like the results of the draft well represent what I have seen on lists, both from myself and from others involved. And it is, in fact, a time-consuming process to review, provide feedback, and get back to it. So there's reasons sometimes where there's not response to things like the updates. And I
Sure.
don't think that should be considered as just being okay with it.
Okay, and to the extent that you felt like I misconstrued your response, I'm sorry about that. I do want to say you did the most comprehensive analysis of the potential solutions to anybody, which is
Well,
what
Thank you.
I
That's
appreciated.
thank you. That's a little terrifying though, because I said, and even said afterwards, that I didn't feel like I was qualified to do the analysis other than to say, don't do this, and then things proceeded from there.
For what it's worth, thank you.
Lauren?
Jumping the line really quick. To Brian's comment that the signature algorithms are sort of more important than the encryption algorithm, which is, in my opinion, totally understandable because based on where some of that work is used historically. So the encryption mechanisms are newer. So I'm newer in terms of usage because of the JWT and signed tokens and so on. So encryption there is less common, but they're also outside sort of the classical OAuth JWT type of usage. There are also other use cases where people do use encryption. And so I think that's fine. So not everyone sort of sees the same urgency, but I see a need, for example, in these IoT use cases, specifically with COSI, a need for using the encryption mechanism, and specifically the ephemeral static Diffie-Hellman.
Just maybe to clarify a point there, to Hannes's, I do use and implemented over 10 years ago the JWE, the Jose level encryption. So it's certainly not, I know it's not used as much, but it's not for a lack of use or lack of need. There's a lack of need in the way that the negotiation occurs and the way that data is usually exchanged for the fully specified versions of ECDH, ephemeral static, not for the algorithms themselves. They're being used in practice right now.
But it's also JWE doesn't imply sort of ephemeral static Diffie-Hellman either. So there are lots of different, as we all know, like both COSI and HOSI are full of algorithms of different ways to do things. And I know.
Algorithm, Jose, so it kind of does imply it.
No, you can use encryption, the JWE, and also the COSI encrypt in many different key exchange mechanism, and the ephemeral static is only one of them. So you can just go for something super simplistic and not use any of those more complicated mechanisms. That's my point. So just because you don't see, or you think you don't see problems in with elliptic curve Diffie-Hellman with the algorithms combinations doesn't actually mean that they don't exist.
Lawrence.
Lawrence Lundblade. So I'm kind of trying to come up to speed on this a little quickly. So, but my understanding is that the proposed minus 254, that's ECDHES, is basically a fully specified version of minus 29 that exists today, right?
Not having memorized the numbers, it's a fully specified version of something.
Yeah,
That's
so
already
so minus
registered.
29 is, ECDH ES with a AES 128 key wrap, and then minus 54 says it's fully specified to the NIST curve P256. Okay, so my comment here is that in Prague, there was an attack presented in the LAMPS working group about, we've been calling it the LAMPS attack, and we've been discussing this heavily on the COSE mailing list. The minus 129 and friends are vulnerable to that attack, and I think we have to do something about it, and I think the only way to do something about it is going to be, it's going to be a new number. It can't be, you can't fix it without a new algorithm ID. So my comment here is, should we be registering minus 54? We probably shouldn't register minus 54 until we figured out what we're doing about this attack and the approach for that. What's that? Yeah, okay. So, but my comment for this group is, don't register minus 54 until we figure that out, right? Which, I don't know if that's imminent or not, but it doesn't seem like it to me. Thank you.
Okay, oh, sorry, you're next.
So it seems to me like there's a fair amount of consensus around moving forward with everything other than the ECDH, which seems to be more controversial. Is there some way to, I mean, it's not unheard of to combine and or separate specs. Do we want to consider perhaps moving the ECDH stuff to a separate specification where we can have more ongoing discussion and debate while not blocking the other algorithms which people seem to be keen on doing? So what do the authors feel about that?
I think the reasonable compromise along that line is to do something along of what Brian was suggesting, which is let's not register new ECDH algorithms in this draft. But at the same time, the working group did a bunch of analysis on what it would look like to do ECDH registrations, and that's in an appendix. And I would propose to leave the appendix there, but say that there wasn't working group consensus to register any of these at this time, but future specifications could do so. But I don't want to pull all the working group knowledge that we gained about debating ECDH out of the spec, preferably.
Hi, Justin Richer, and I'm actually going to suggest something that Mike suggested to me about a decade ago when I was in a similar situation with a bit of a draft that was more controversial than the rest, and that's that I'm going to propose that the authors take and create individual drafts, not working group drafts, but individual drafts that perform the separation surgery in a way that they think makes the most sense, to sort of like show this is where the dividing line would be between this piece and that piece, and bring those back to the working group to say, this is how we could go with the next draft. Do we want, this is what it would actually look like, as opposed to sort of vague lines around this section would be out, but the appendix would be in, and stuff like that. I would propose that to the authors. It worked out pretty well when you suggested I do it.
I don't remember the details. We can have a hallway
I
conversation.
was dynamic registration.
Okay.
With yeah.
In this case, however, in Brisbane, we did something pretty equivalent to that. We decided in Brisbane that we would have the mailing list discussion about ECDH, trying to categorize what that solution would be. So as you said, it wasn't vague. There's a big table in that email that's cited in the slides, and people responded to that. That wasn't a draft, it was a detailed email discussion. So I feel like we've already covered that ground in this case. And that's what the working group told us to do in Brisbane.
We've got one more person in the queue. We do need to move on. I do think the result of all of this is we're not quite ready for another working group last call. So I think we need to have some additional discussion on the mailing list to figure out what ways forward we're willing to go with. And Philip, you have the last word. Well,
Thank you. Mike, from my recollection of the appendix, I wouldn't mind if the appendix stayed in a version of the document where there is no actual registration, sans the fact that there are actual identifiers mentioned in the tables. And I would like those to be gone from that discussion, because those identifiers being there will actually lead to people implementing them anyway.
you're done. Do you have any last?
I'd like to understand what it's going to take to move forward. Right now, it seems like we're stymied based on your conclusion.
Well, I thought there was a couple different proposals of ways, like are the authors willing to pull some of it out?
Are there what?
Are the authors willing to pull some of this
So
out?
You suggested that we do a version of this that didn't register any new ECDH algorithms.
Right. We could turn that around tomorrow, and maybe we
Right.
do. Maybe we proceed with that.
Philip also suggested that the appendix would need to be modified to remove the examples, which include algorithm identifiers. Otherwise, people will just read the examples and imagine that.
I could turn it into prose rather than apparent identifiers,
Okay.
but I don't want to. I don't think it does justice to what the working group did in the last 4 months if we just delete it.
So can we just ask that specific question on the mailing list? Would it be okay if we did turned it into prose and left the appendix in place
Okay,
and took the registrations out that are problematic for now?
that's fine.
Okay.
I mean, I'd like to solve the core problems. We've tried to
Right.
solve all the problems, but there doesn't appear to be an appetite to do that.
Right.
All right, thank you.
Okay, I will walk you through the COSI HBKey document. So here's a short summary of what it is in case you haven't been, for example, in the COSI group or listened to one of the earlier presentations. So, so we are talking about like following the discussion we just had about JSON web encryption, and HBKey is a variant of public key encryption, which uses it's a CAM-based implementation key encapsulation mechanism, which given a public key of a recipient encrypts a message or any payload to that public key following these CAM-based APIs. It was initially designed to support the classical traditional public key-based algorithms, but then it has also been defined to also cover sort of the hybrid mode, or even people are debating now post-quantum use in HBKE, but that's ongoing work, and who knows where that will go. The draft itself specifies 2 serializations following what is already done with the JSON Web Encryption. There are 2 modes in there which offer different features. One mode is which is called the integrated encryption mode, which is targeting a single recipient only. It's a kind of an optimized version of the second mode. Brian, you're already in the queue, and I have not even finished the first slide. Okay.
I don't want to be pedantic. Well, maybe I do want to be pedantic. I don't know, but you started the introduction here and said you were going to talk about COSE HPKE.
Oh, Jose,
just-
I mean, okay.
Yeah, okay.
Sorry.
It's kind of, but
Did I
maybe
make a
that,
mistake?
well, it's maybe a relevant mistake given the desire to have things all be the same and not the same and the differences and so forth. But we are talking about Jose here, right?
Yeah, I meant I was meant if this slide is to remind what the work is about in case you haven't seen the discussion in COSI or a previous presentation. This is a newer document, so you may have missed the Brisbane presentation.
Perhaps I misunderstood what you said here, though. I did see the Brisbane,
Yeah.
but thank you. That's clarifying.
Yeah, so there's also a COSI-based version which differs, but I didn't go into the details on how it differs because it obviously relates to details in COSI and Jose or Jose. And most people probably don't care about those differences because like the use cases for the 2 are somewhat different, I would argue. But anyway, I digress. So the second mode is the key encryption mode, which offers the ability to encrypt the payload to 1 or multiple recipients. So that makes it different to the former one. And it's, of course, or not of course, but it is more sort of complicated because it has a different, an additional layer of encryption. While in the integrated mode, you can encrypt the payload directly. In the key encryption, as the name already indicates, you first encrypt the content encryption key, which is then used to encrypt the content. So there's one layer of indirection, so to speak. Okay, so that's the 1 slide summary of what you probably have heard already in earlier presentations. Next slide. So since the document was adopted, there was another 2 versions published. So we are version 01 here. There was some feedback on the mailing list. Actually, there was more feedback than I thought. Feeling a little bit like we are rehashing some of the debates we had in the COSI working group. Ori has been working on some early prototypes. And of course, as things change, we need to update the prototypes. Next slide. I think this slide, I think, is useful to explain some of the discussions on the mailing list, which were also the same reasons why we had lots of discussions in the COSI list. So there's some similarity there. So when you use HPKE, there's a possibility to include application data or context information into the key derivation or into the authenticated data. And there are 2 ways to do so in HPKE, which are shown on the slide, HPKE info and HPKE AAD. And they have slightly different properties, go into the different API calls. The HPKE specification, as you probably remember, specifies different APIs, and these APIs allow you to pass in various different parameters. And so I briefly summarized the differences here. So the HPKE info has a fixed length field versus the AAD has no length restrictions, but the former one is used for one-shot APIs versus the later one is available in all APIs. Okay, so the important aspect here, in my opinion, is the question at the bottom, namely, what information, what context information, what application layer context are you incorporating into the HPKE key derivation? Because that is important because it allows you to bind the endpoints and also the algorithm information that was in reference to what Lawrence previously said on a microphone. So if you don't bind that context, then an attacker is able to manipulate some of that information, and potentially, depending on the usage environment, which only the application developer knows, it can then perform some attacks. So you need to be able to flexibly include that information, which of course pushes also some responsibility to the application
Hun-
designer.
Sorry, I hate to interrupt, but
Oh, sorry.
we only have 20 minutes left and we have two more
Oops,
topics
okay.
after this. Can
Okay,
we-
then I'll
You've got about 7 minutes to do the
okay,
highlights.
I'll do. Okay, then I okay, next slide.
Sorry.
Thank you. So here's an example for the key encryption. Please pay attention to the recipients field, which is sort of the interesting one here. So you have the encrypted key field. Sort of the recipients field is sort of the place where we encrypt the content encryption key, which is then used on the outermost layer to encrypt the payload, which is here called the ciphertext. So that's, I think that's the important part. Here, also the fields in bold indicate the important fields with regard to this, the use of HBKE in this example, namely the encapsulated key, which is the CT field from the chem that is output of HBKE, and yeah, of course, the algorithm field, which indicates like what combination of HBKE algorithms we are using. So in this case, the NIST P256 curve with SHA-256 and the AES-128 GCM, which is then used to encrypt the content encryption key. Okay, so that's the key encryption one. The other one, which turned out to be a little bit more controversial on the mailing list, which is, next slide. This is the text for this. Next slide. Which is this integrated encryption mode, which is sort of only for a single recipient. So there's no recipient structure here, as you can obviously see on the screen. And that is kind of an optimization to the earlier mode. And so there have been some sort of a side effect of this is that it would require an update to the JWE RFC, which I think was, in my reading, the controversial aspect here. Next slide. There's also some text explaining this. This is also the note that it requires this update. So next steps. It's I don't know.
So I think because I took a look at these.
Mhm. Do you think these are too
I-
detailed to answer here?
These are way too detailed for us to answer
Okay.
here. I think if we work this week with a few of us, we can come up with some consensus calls that we can put onto the mailing list, if that's okay with you.
Of course.
Okay.
Yeah.
If you don't mind.
No, no.
But
it's perfect.
everybody
Yeah.
in here and online, obviously, please take a look at the last two slides. They were, Ori also posted a message to the mailing list that had roughly the same content in it. And we're going to do a couple consensus calls to figure out a way forward for pieces of this document.
Yeah.
Okay?
That would be great. Yeah, there's obviously a lot of details and a lot of reading that needs to be done. So it's yeah, probably not
Yeah,
super easy.
we're not going to be able to formulate those into consensus calls that we can do here.
Yeah.
This in
Right. So
in 15
right.
minutes.
So it would be good if you formulated those two as separate questions to the list.
Okay. Yeah, I didn't want to really do it myself
Right.
because but having a discussion here and then finding out together with the chairs to what possible useful questions to the group would be. I noticed just because there's a huge overlap between the people participating in COSI and Jose. Like I've been witnessing this, and Lawrence, I'm surely will agree with me. Like we've been through like 1.5 years of discussion in COSI on this, and we've been up and down the solution space and back and forth, and that's why I started implementing some of that early on in COSI to change it like 5 times because people change it, and I think we're closer
on the
to-
list.
Okay,
Next.
All right,
next slide.
um,
Next topic.
Yes, next topic.
Oh, yeah, yeah, and I apologize. We probably should have asked for a little bit more time, but we
No,
did not
that's
do
okay.
that, so. um,
I will speed that up really. How much time do you have?
We have 15 minutes, 10 for you.
Again, I missed Brisbane. Yeah, that was a copy and paste mistake. Or hopefully. So if that slide deck looks familiar, then I uploaded the wrong slide. So you know this already, so I don't need to tell you anything about the need for post-quantum crypto algorithms. I also don't need to remind you about the competition that NIST is doing and what all the different algorithms are. There's a great document in the BQIP group, which focuses on BQC for engineers, which explains all this about chems and how the API calls look like with the keygen and encapsulate and decapsulate, which is very similar from an API point of view than what we just talked about in HPKey. So that's why good to have these talks next to each other. Next slide. So look at it when you find time. So there's obviously this also discussed in various different groups that transition path between the traditional algorithms and then the post-quantum crypto algorithm and with hybrid schemes in between. I just talked about that sort of ongoing work in HPKE. And this document is about the sort of like the end state where traditional algorithms have been entirely been replaced by post-quantum crypto algorithms. Next slide. This is the API. Next slide. Key encapsulation mechanism and the decapsulation also. If anyone cares about the details, I can explain them. Next slide. So in the document, you find a couple of Cypher Suite registrations for these 2 modes that I explained earlier. One mode where, so this is modeled very similar to what I just explained. The key encapsulation or the key encryption or key wrapping mechanisms was this 2-layer approach versus and that's the lower table, and the upper table is this, and we keep changing names. Here it's called direct key agreement or the integrated encryption mode, where we have only one recipient and it's kind of the optimized version. And pending a decision on the discussion in HPKE, we would change it either to have both modes or to have only one mode. In COSI, we have the 2 modes because they are the efficiency is key because of use cases in COSI in general with the way how things are encoded there. Okay, next slide. Yeah, I just talked about the single and multiple recipient setup. Next slide. So the single layer setup, I will skip that. Talked about this. Yeah, next one to show an example. So this is sort of the single recipient mode, and again here we have. Like in the previous presentation, there's obviously a need to register the algorithm, but in this case, like obviously an easier task with the post-quantum crypto algorithm, and the output of the encapsulation operation is then included in this newly defined field, the ChemCT for ciphertext, and yeah. Next slide. This is sort of the multiple recipient mode with the recipient structure, which mimics what we've seen earlier. Here again, the recipients, and there may be multiple of them, but then obviously it wouldn't fit on the slide. But it would encrypt the content encryption key here in one of the recipient structures, and then the actual payload, the application payload to be encrypted would then stay outside. And so you could, for example, encrypt a payload once and then have multiple recipients each get the content encryption key and can then encrypt the outermost payload. So there's by doing this, there's also an efficiency gain, specifically if you have long payloads like firmware or software or anything big. Okay, next slide. So you see a pattern here in the type of style, obviously taken from the discussion. So on the questions to the group is working group adoption or, and of course, feedback as well. If you have any, or if you're working on this, already working in other groups in the IETF on post-quantum crypto, like John is with the work he has been doing in a group on at the hackathon. So that would obviously be, any feedback would be interesting.
Okay, we have about 2 minutes. Does anybody have any feedback on whether or not we should do a call for adoption on this document? Yes, okay, I see a thumbs up. I don't see any thumbs down, another thumb up, a couple more thumbs up. All right, we'll do a call for adoption on the mailing list for this document. So Hannes, is this? Come back.
You've left yourself 8 minutes.
Yeah, okay. But actually, I kept it really short. So this is a document I've been presenting twice already. The first time in last November. And next slide. So Yaron joined us to this document. So and that's the sort of the submitted version after Yaron joined. So we had a call for adoption on the mailing list. So we've been left hanging a little bit with that document. There was a call for adoption. There was quite some positive feedback. Mike spoke in favor, so did Ori, Giuseppe, even Ilari spoke in favor, which is it's like almost, for me at least, something very unusual. But then Carsten jumped in and said he wasn't quite sure, the scope doesn't seem to be right. And so I've actually used this meeting to find out like what could I possibly do to address this. So we collected the feedback. There was some content-wise feedback as well. Carsten did actually a detailed review. So if he's online, thank you, Carsten. Captured that in this GitHub repository. Next slide. Oops, and I saw a typo in the status here. So initially the initial idea was, oh, couldn't we have a more generic document, like as the title suggests, guidance? We want to capture some of the this attack, the LAMPS attack in there, and so on. And I think now we at the point I published this LAMPS attack which will be covered in tomorrow's COSI session in a separate document. So didn't include it in here, didn't quite fit, like looked a little bit awkward, a collection of random things. And so my proposal here is to change the title of the document to what's in the document. Sounds revolutionary, but which would be security aspects of key identifiers on COSI and HOSI, which was the main reason we started the work on the document. I think that's quite sort of like, it's a very narrow focus, but on the other hand, it would be a document that would soon be finished, and I think it's a pressing issue. So that's my proposal on moving this forward. I would appreciate feedback.
Is there any feedback from anybody in the room? I am seeing thumbs up. So I think we have 5 minutes. So can you just send a quick note to the list proposing that? And then depending on the feedback, we can do a short second call for adoption.
Yeah. I can also resubmit that now the sort of blackout period is over.
Yeah.
And I can resubmit the document with this new title and change the abstract, and then would make it more meaningful if someone actually looks at the document again.
Yes. Well, since there are people doing thumbs up, I'm assuming there are people willing to look at the document. So, all right. So yes, if you could do that, that would be wonderful.
Yep.
Also, for all of the working group adopted documents, since we are in the process of moving everything to the IETF-owned GitHub repo, if you all could, each of you authors could do the work to move it over, that would be fantastic. And with that, I do apologize for rushing through the last few topics, but I think we got through them anyway. So any other questions or comments, any other business? All right, so with that, we end 4 minutes early. This will end it, and then if we need to, I step away from all of